Hey, this is Rob from Principia Tutors and Consultants, and today we're going to be talking about an expansion of cross multiplication that I've termed cross multiplication and division, and some associated manipulation techniques. And what this is going to allow us to do is to solve problems faster, make less arithmetic mistakes, and also reduce the amount of manipulations and computations we need to solve problems, which results in less mental strain, which is particularly important for a long test like the SAT, where you're just going to be tired by the end of it. So what we kind of want to get away from and what we don't want to do is this problem, y divided by 5 is equal to x. If we want to get y by itself, we're first taught when we're learning algebra to multiply both sides by 5 to cancel these 5s out and get y is equal to 5x. Which is correct, but it's not the easiest or fastest way to do it. There's nothing mathematically wrong with this, but there is a better way to do it, which I will explain on the next slide. Okay, so quick review of cross multiplication. We're kind of taught that we should, when we're cross multiplying, we take this b value and multiply it over and up, like over there, and we take the d and multiply it over and up over there, and that's going to get us a d is equal to b c. And this is true, and we can do this manipulation, but it's important to understand where this kind of is coming from. So why this b is moving up to this c is, let me delete these arrows really quick, is if we go ahead and multiply both sides by b, we can cancel out these two b's on the left, and we're left with something that looks like a is equal to bc divided by d. So this kind of gets at the first point that I want to talk about is, when we're doing cross multiplication, it's not that we need to take both of these denominators and move them into the numerator. We can just do that with one of the arrows. So we could just take this b and move it up here. And so on a test like the DSAT, maybe we want to keep this d in the denominator, and so we don't actually want to move it up into the numerator. Another addition to this is that this arrow actually goes both ways. So we don't need to, it doesn't need to necessarily be this b moving up into this numerator. It could very well just be this c moving back down into this denominator. Similarly, could move this b also down there, or we could move both of these at the same time up here. Additionally, this works with the other side. So this a and this d can kind of swap places with each other if we want. I could move this a down here, and I could move this d up here. And let's just move back for a second. What you'll notice is we have BC divided by DA, and then there's kind of nothing over here. If you're ever left with nothing over there, this is really just 1 over 1. Okay, so we just learned that we can move kind of any number or any variable diagonally. We could move this b up and make sure you take the whole thing when you actually do that. Or we could take both these guys and move them back down. I'm just going to move this c. I'm just going to move this c guy back up here. One other thing that we want to start doing is we want to get away from canceling out variables. So we don't want to do something like multiply both sides by b and cancel these guys out. And what this will leave us with is a is equal to bc divided by d. So let's just make a note of what we have over there. A, and it's really a over 1 is equal to bc divided by d. Now let me delete this real quick. What we want to start doing in our head, and what I'm doing exactly what I'm doing in my head, is I'm imagining picking up this value and dragging it over here. And this is really a small change between writing it down and canceling, but it's going to save you about a second. And when you're doing 10 manipulations a second, or 10 manipulations a problem on a 44 problem test, that's 440 seconds, which is a little over 7 minutes. So we really want to get comfortable with picking up these numbers and dragging them across fraction signs, over and across, always going diagonally. So we could take this a, move it down here. We could take this d, move it up here. We could take this c, move it over here. This just makes the manipulation process a lot more fluid, and I honestly think it's more fun. You have a lot more fun dragging numbers around than you do like writing down and canceling stuff out. Okay, let's look at the mirror process for addition and subtraction with that manipulation technique, that dragging manipulation technique instead of canceling out. So we have x minus 5 is equal to y plus 7, and let's try to get x by itself. And the way we're taught to do this is to add 5 to both sides, plus 5 plus 5. And summing that all up, we get x is equal to y plus 5 plus 7, or x is equal to y plus 12. And I'm going to take this and just put it aside for the moment. And let's return to our start. So what we can do, kind of a very similar process, we can, instead of adding plus 5 to both sides, we can imagine picking up this negative 5, dragging it to the other side. One thing you do have to remember, though, is when you do this with addition and subtraction, you have to convert whatever sign it was to the opposite one. So it was -5, and we got to make that a +5. And what you'll see is that we have x is equal to y plus 7 plus 5, which is exactly what we had over here. It's a small thing, but it does save you about a second. And on a long test like the SAT, that really does add up. So similarly, let's take this +7 and move it to the other side. Drag it over there. We got to remember to convert our sign. So it was +7 before, turn it into a -7. Cool. It's a small thing, but it really does add up. Okay, let's look at a problem from an actual SAT that we can implement this technique on. The problem is 1 divided by 7b is equal to 11x divided by y. The given equation relates the positive numbers b, x, and y, which equation correctly expresses x in terms of b and y. So we're trying to get x by itself. That's shown by the answer choices. They all just have x by itself. So let's start by writing the problem down. 1 divided by 7b is equal to 11x divided by y. And so let's use the technique we talked about of dragging and cross multiplying and division. And so we got to get x by itself. So I will start by taking this y, moving it to the other side. Then I will take this 11, drag it to the other side. And this is really 11 times 7, so let's add a dot. And on the top, it's really y times 1. So this simplifies to y over 77b is equal to x, which is answer choice C. So that was really fast with this manipulation technique. And when I'm doing this problem in my head, it really only takes me 2 seconds. I see 1 divided by 7b is equal to 11x divided by y. Move the y up here, move the 11 down there. Oh, y over 77b. That's your answer. Okay, another problem for you here. We got ax minus y is equal to bxy. The given equation relates the positive number a, b, x, and y, which equation correctly expresses a in terms of b, x, and y. So we got to get a by itself, which is right here. So let's use those manipulation techniques and that cross multiplication and division like we did before. So we have minus y. We're trying to get this a by itself. So let's take this minus y, move it to the other side, and always remember to flip your sign into a positive. Now we have ax is equal to this whole thing. Important to recognize that both of these things are over 1. So we can apply that cross multiplication and division process. And so we're going to take this x, pick it up, drag it over here. I'm just going to delete that 1. And we get a is equal to bxy plus y over x, which is answer choice A. Again, pretty fast. It was slower because I was explaining it. But when I see this problem, ax minus y is equal to bxy, just move that y to the other side. It's a plus, divide by x, bxy plus y divided by x. Answer choice A. Okay, one last problem for you guys, and it wants us to isolate x. It is equal to, the problem says abc divided by the square root of u times v is equal to e f squared times g divided by the quantity x minus 1, all that times y. So go ahead and pause the video and make sure you try to solve this with that manipulation technique of just dragging the numbers around and that multiplication and division moving from one numerator to the other denominator. So yeah, go ahead, pause your video and try it yourself. Okay, so to solve this problem, we want to get x into the numerator. So I'm going to take this whole quantity x minus 1, drag it to that numerator. Now let's take the square root uv. Yes, this also applies to square roots. And so take this whole thing, move it to this numerator over here. Last step, let's take this ABC, drag it over to the bottom. And I'm just going to clean this left side up a little bit, get rid of that division sign, get rid of these parentheses, and we are left with x minus 1 is equal to e f squared g times the square root of u times v divided by abcy. One last step, we just have this minus 1. So let's take this minus 1 and make it a little bigger, and then drag it over to the other side, and then make sure you convert that negative sign into a positive sign. Just like that. And that's your answer. So it looked pretty complicated at the start, but it's really pretty simple, and we just got to move some numbers around, and we don't really need to do any math or cancellations or anything like that. Okay, so to recap, we saw that it shouldn't be called cross multiplication. It should be called cross multiplication and division, which is represented by these two-way arrows. And additionally, we don't need to do it to both sides at the same time. We don't need to take this d and move it up here and this b up here. We can just do that with one of them. We don't need to do it with both. Additionally, we can do multiplication, division, subtraction, and addition as fluid movements. When you think someone might be really good at math, it might not necessarily be that they're better at math. It might just be they're doing it in a little more simple way, which just allows them to do it a bit faster. Additionally, this will save us time on every problem involving manipulations, which really is every problem. It reduces the mental toll of arithmetic, which is particularly important on a long test like the SAT. You're just going to be tired by the end of it. Additionally, this is also a learned process, so start practicing and implementing this now. What this is also doing is this is training our working memory. And eventually, at some point in math, we can't always represent, we have a bunch of moving processes, like in trigonometry, we talk about angles rotating, and you can't really write that down. You need to really imagine having this thing and rotating it like that. So it's helping train our working memory, which will come in handy later when we get further down the line in mathematics. Great. Well, my name is Rob from Principia Tutors and Consultants, and I hope you learned something.